Welcome, everybody, to this episode of Unlocked. Super excited to have Jacob here with me today. Jacob, welcome to the podcast. Your second time here.
Yeah, thank you. It's great to be here. We have a setup this time, which is
Yeah,
awesome.
yeah, you're in the Valkey studio this time, which is getting more and more mileage more recently. You're speaking at Unlocked this year?
Yes, yeah. I'm going to be kicking things off with the keynote at Unlocked. Really excited. I have been preparing a bit. I'm just excited to kind of talk about my favorite thing, which is boring things. Which is the ability for systems to kind of handle operating on themselves at 3 a.m. Right. So the talk's going to be about the 3 a.m. test, which is basically how systems get battle tested at 3 a.m. and which kinds of systems are capable of handling themselves autonomously, right, and with minimal operator intervention. And I'll bring in Valkey too and talk about all the great things we're doing in Valkey to make it more boring for operators. Yeah.
This is exciting. Yeah, we're gonna have an exciting talk about everything you do behind the scenes and the community does to make Valkey boring.
Yes. Yeah.
I love the way you framed it. The first time you're talking to me about it, you mentioned that some of the most renowned systems that we respect are very boring, like Postgres, ext4. They're just boring. They just work. And that's what makes them exciting.
Yeah, I mean, like you don't go up to someone on the street and you're like, hey, like, did you see the new patch to ext4 or whatever? Right. Like it's the kind of thing that's just totally invisible to most people, but like it empowers all these really exciting products that, end users actually end up needing. It's good to acknowledge the sophisticated, invisible work out there. Even if to many people it's boring, right?
Yeah, Kyle often mentions this too. Valkey is a sum of very tiny little improvements that have a compounding effect over the years. And they end up making the system boring. They end up making the system more efficient. And they end up making the system more performant. You've been with Valkey from the very beginning. You're in the TSC, the Tech Steering Committee as well.
Yeah.
Tell us a little bit about that.
When the license change happened, I remember I was just on my computer and I got a message and it was just like something big just happened, right? And that was all I saw. And I was like, what does that mean? And it turns out, the Redis license change happened. And I'd actually been kind of thinking about this in the back of my head for such a long time because, I think we had seen this movement from a lot of these, kind of centralized open source projects moving away from open source licensing. I think the most recent one that had made me think about it was like the Terraform and Open Tofu, And so I remember at one point actually talking to Madeline beforehand, and I was like, what is our plan here? And then she was like, we'll just fork. It was, a little scary, but a little exciting to know that, like, we were kind of moving towards this open governance, not having that single vendor. So that was really fun. And yeah, since then, I've been contributing. I've been every week we have multiple meetings. So kind of showing up to the meetings, just kind of that invisible work that goes on to think about every little feature, every little config we're adding, and making sure that the incremental changes we're making are positive. Last year I had the opportunity to work on atomic slot migration, which was really fun. It was something that we had been wanting for so long in the Redis and Valkey community. And so, that was kind of my first chance to have this like kind of major feature launch. And from that, got to do a lot more in-depth collaboration with all kinds of folks. And that culminated in, now I'm an official maintainer of the project, technical steering committee. That comes with responsibilities but it's also, a great honor to have. And, the project is something I'm very passionate about.
It's great to see that passion and the results really show up in the community. How much of the innovation tokens in these tech steering committee meetings go into, well, this would drop the number of cores required for Valkey, or what should be reserved for Valkey Enterprise?
0. Yeah, I mean, we're not optimizing at all for selling anything, right? And that's just the beauty of open source is, we sit around in a room and we just think about how do we make this better for our users, right? in the community, really. And so, when we're sitting around, we're thinking about these kinds of things that I think languish in centralized, governments, which is like, how do we prevent wire compatibility breakages? Like when we moved to Valkey, like we even like symlinked a Redis server to Valkey server on the default install. And so it's like, if you were booting the server by calling Redis server, it's like you didn't even have to change your shell script, right?
Yep.
Like it would just boot, right? And so like we've sat around for a lot of our time just thinking about what is like every little potential impact of this change. And decentralization is nice because we end up with so many different voices in the room and people that, maybe we hadn't considered before. Like I remember at one point, we were talking about, like maybe we need to get rid of some of this this code that we have for like 32-bit compatibility. And then like I remember some people started speaking up and they're like, we're running this like
Raspberry Pi.
Yeah, well, no, I it was like running on like mainframe or like
Oh,
that kind
wow.
of stuff. Like they were like, we're running this on hardware that like we need this, right?
Okay.
And we were like, oh, we were not aware that people were actually doing that still, which is great, but just so little that you'd think about when obviously my day job, I worked at Google, right? And like we just have such a kind of monolithic tech stack where it's like everything is conformant, right? And so it's like it's super easy to just move from technology A to B, right? And just completely disregard everyone running on A, and it's a forced deprecation and everyone kind of does it. And open source is the exact opposite of that. It's like, we optimize for the minimum, right? Like what is the minimum everyone is running? And if we're going to make a change, we're thinking very strongly about forwards, backwards compatibility, wire compatibility. If you had a config where you were specifying this before and we're getting rid of the config, like what do we do by default? All kinds of stuff like that.
The level of inclusivity and transparency in the open governance model is really nice, I think. But the decentralization has really had a remarkable effect on efficiencies that I suspect would not have happened if Valkey was not born. So many features would very much be in the Valkey enterprise in an alternative universe. Things that really like you don't commonly see in a completely open source version. So for instance, with atomic slot migration and these very large clusters, like you can run a billion TPS cluster, which requires thousands of nodes with Valkey open source. You don't need an enterprise license for that. You can run vector search now without having an enterprise license for Valkey. Did Google have anything to do with the vector search?
Yeah. That's actually one of the projects I worked on extensively was the kind of incubation and formation of Valkey Search.
And Google knows a few things about search, I imagine.
Yeah. We have a couple people that know a couple things about searching at scale. That was a really exciting project. And I think we were taking something that before was gated behind licenses and really required you to run it at scale to, pay someone, right? And we wanted to move it to BSD3, have a fully open source. Anybody can run it. And there's a lot of things that, technical challenges that come up from running vector search or any kind of search on Valkey and not having the centralized layer, right? And so I think, thinking about how it operates with clusters, right? You don't get to just say like, oh, we throw some middleware in the middle and like, it
has to do the scatter gap.
Every shard has, vectors on it. If you ask us for the nearest neighbors, how do we find those nearest neighbors over all the nodes, right? So lots of interesting problems there. It's something I worked on for a while.
I have a question about that. So when I think of Valkey, I think key val, and yes, Redis has, and Valkey has hundreds of APIs, but I thought it was all going to be about key value, val key, but then you add vector search.
Right.
So what's going on there? Are you going to be adding more searching capabilities, or have you added other searching capabilities?
Yeah. And I think, it is a kind of contentious topic. Obviously, Valkey is mostly optimized for like single key access, right? We have other APIs as well that do let you do multi-key things, right? And we support Lua scripting as well, so you could run as many things as you want in one Lua script and do that. But overall, the kind of model has been like, one key one value, and you're kind of doing these point lookups, right?
Mm-hmm.
But we were seeing emerging need for very fast, very high throughput search use cases. Either you're searching over your data that you've cached, or you're kind of creating a bespoke solution that utilizes Valkey for that low latency, really high throughput. And really the most important thing is the predictable latency, right?
Mm-hmm.
And so we saw a lot of use cases for stuff like that, especially with the way things have been going with AI. Obviously, that like vectors are becoming a very important first class primitive.
Yeah.
And so we started thinking about secondary indexing, which you store something as a key value, and then
Mm-hmm.
we also in the background index it into some way that you can access it, not as a point lookup, right? More as like, I have something and I want to find all the things near that, right?
Mm-hmm.
And yeah, we've been continuing to iterate on that. One of the exciting announcements of this year has been Valkey Search 1.2, which adds full text search capabilities.
Nice.
So not only are you able to search over, vectors, but you could also do text searches. We for a while had the ability to do like filtering on your
Mm-hmm.
vector searches, but you weren't able to do like, so you could say, give me all the vectors near this vector that have this other field
Mm-hmm.
that like have color red or color blue, right? So we've had that capability, but you were never able to just say, give me everything that has color blue, right? And so we added that capability. We also added all of the complexities of searching,
Yeah.
like tokenization, stemming, all that kind of stuff. And we're really excited to get some feedback on it and get it out and, really give you that predictable latency, high throughput that you want out of Valkey, while also addressing some of those non-point lookup scenarios. Yeah.
Can I combine Valkey search and vector search in the same query yet? Or is it only filtering with vector search today?
Yeah. So today we still only have the ability to do filtering
Okay.
over the vector search. We don't have this hybrid concept yet, but it's something we're really exploring and something we're looking at for the next release, next feature release of Valkey Search, is to be able to combine, a text search that gets you a score and a vector search that gives you, a distance to each
Mm-hmm.
vector in a meaningful way, using, the algorithms we all know and love, like reciprocal rank fusion,
Mm-hmm.
EM25 scoring, so that you can get that really high quality search results, using both semantic and the token search, right? Uh, while still giving you that low latency that you want out of Valkey, right?
Now, a secret menu hidden undocumented feature of Valkey vector search is that it does support scatter gather. I,
Yeah.
for the longest time, thought that we just hadn't implemented it yet until Madeline was like, I'm looking at the code, but it's not in the documentation. But anyways, so vector search does have scatter gather. Does full text search support scatter gather yet, or is it
Yeah.
optimized for single node?
Yeah. Everything is optimized for, I would say, optimized for single node. And by optimizing for single node, it gives you a lot of benefits when you're doing scatter gather. However,
Mm-hmm.
scatter gather, a lot more complexity involved there,
And there's
right?
more heuristics available that we may not have gotten to, I would imagine.
Yes. Yeah. We're definitely still, iterating, but you have to make a lot of difficult decisions. It becomes just, it's a distributed system problem, right? And so you have to think about, how do we sacrifice recall,
Mm-hmm.
availability, right? One node is down. Do we give you the result? Do we tell you that we couldn't get all the results, right? And then when do we give up on that other
Mm-hmm.
node, right? Obviously, one huge thing, I've said it many, many times, is latency in Valkey, right? And so it's like, we don't probably want to sit around and wait for that node to
Yeah.
give us a response for very long at all, right? Um, so, and ultimately you end up taking this max function over all the nodes, right? When you're doing scatter gather, but it does give you the ability to really trade off between, do I want to scale out all the indexes we support? Do I want to scale out the number of documents I'm searching over?
Mm-hmm.
Or, do I want to scale out the QPS I can get over a smaller range of documents,
Mm-hmm.
right? The other thing you can do in a cluster environment is you can now do these like single slot indexes, right?
Okay.
So I could say, if I have a lot of small indexes,
Mm-hmm.
I can ensure that index is only served by one node, right? And that would allow me to continuously add more indexes with more nodes and get higher QPS.
And when you say ensure that it's served by one node, it's localized to a slot, so that
Yes.
if the slot split, you're still contiguous for that particular index.
It's localized to a single slot, right? And all the documents would also go into that slot, right?
Okay.
And that would basically just ensure everything stays on one node at a time, right? So you can kind of think of that index becoming part of the atomicity that you get with slots.
This has implications. Normally, people would imagine their caching layer as ephemeral data that can just go away and get repopulated. But as soon as now you have my indexes, the resilience of the Valkey stack
Hmm.
and the replication, that starts to matter a lot more.
Yeah.
How do you think about that? And is that a direction that you want to get Valkey to get even better at?
Yeah, you're really hitting on an important point. The, you know, I'd say less the indexes are, they matter, but like if your index gets dropped, you usually can you recreate your index, right?
Hmm.
But you have this data now like vectors, right? And to actually get a vector, you need to make an API call
Yeah,
to something and
like an
get that
embedding
embedding,
service. Yeah.
right? Now you actually have a cost associated with a cache flush, right? Or at this point, maybe you don't even call it a cache, right?
Hmm.
You have a cost associated with flushing that key, right? Because now you actually have to go spend money to go, spend an API call, get that embedding back, right? So yeah, definitely something we're thinking about is like, how can we continue to harden the durability guarantees that we're giving people with Valkey? Valkey is very much leaning into the kind of AP realm of cap theorem, right?
Hmm.
So
Hmm.
we always try to, we don't care about consistency. Everything's asynchronous replication across nodes, right? Which works very good for a lot of caching workloads. Maybe, this is some ephemeral data, right? And like failover happens, you move backwards 1 second in time, but it's like, if you're watching a car on a map or something, right? It's like the car moves back a little bit and then moves forward again as the sensor data comes back in. So for a lot of people, they don't care, right? And the AP is a great trade-off. And where Valkey lives, maybe there's a lot of, that's a good starting point, right?
Hmm.
But now we're moving more into where people care about CP
Hmm.
and ACID guarantees, right? Not just at a single node level, but at the cluster level, right?
Hmm.
Um, so yeah, durability is one initiative that we have a working group on, and we've been talking a lot. You have to talk about all of the distributed systems, things that we know and love there, like Raft, talking about Paxos,
Consensus. Yeah.
yeah, all those kinds of things, and just how to do the CP style replication, which effectively means some amount of synchronicity between the nodes, right? Um, but definitely something we're looking at for the purposes of vectors, especially.
The consistency is one big part of this, but the there's emergent behaviors that can show up if you're having eviction or if you're dropping one or two objects here and there.
Hmm.
And that usually you don't expect your search queries to come back incomplete. It's maybe even more forgivable in the vector case because it's supposed to be a heuristic and there's recall
Hmm.
anyway. So if you drop one or two, maybe it's not the end of the world.
Yeah.
But for search, it could actually, you could drop the most relevant item for a particular search, maybe the least popular, and it might get evicted. So how does this evolve the way people think about eviction in
Yeah. It's
Valkey?
a really interesting intersection of two concepts, right? I think eviction, obviously a lot of the algorithms we have there made for caching, right?
Hmm.
Least recently used, least frequently used, all the great ones you learned about in university, right? Uh, but I think when it comes to vector and nearest neighbors, you may have to think about new eviction mechanisms, right? Maybe you want to evict the things that are furthest away from
Hmm.
some centralized point, or, uh, we've been talking a lot about this concept of semantic caching, which is coming
Yeah.
up a ton with AI. You're running a query, right? And you want to take the result of that query to the LLM, right?
Hmm.
Or whatever expensive place you're sending it to. And you want to store that query somewhere
Hmm.
with the result, right? And then later, if someone gets a very similar query, you can give them potentially the same result. Um, Lots of complexity in that problem, right?
Yeah.
And nuance, right? Uh, but like one thing we've been talking about is like, how do you ensure that, if you're thinking of Valkey as like a semantic cache, right? Like, how do you track what is the most frequently queried, like what is the heat map of this
Yep.
vector space, right?
Yeah.
And where are the cold areas? And maybe we should be kind of focusing on evicting those cold areas, or trying to keep the heat density strong in those areas, right?
It's a really hard problem because some of the colder areas, like they could be the anomalies that you're trying to
Right.
detect anomalies on. So it's
Right.
really hard to find a one size fits all.
Yeah.
Solution. And my intent here is not to critique what Valkey has, but just to encourage everybody that, hey, there's going to be some very cool seminal work that's going to happen at the intersection of caching, searching, and indexing.
Right.
And I'm pretty excited about it for the future. Like
Yeah.
anybody who's working on Valkey right now is solving some of the hardest computer science problems out there.
And I think we've been always trying to think about like how can we apply these indexes to the caching problem themselves, right? Like, so always caching has been like, you know, you take something, you look up a point, right? And you store that point in the cache, right? And you know, there's some query caching people do, right? When they go to SQL, you get a query result and you cache that. And the next time that query comes in, you've got the result, right? But you're not losing anything by storing that, right? It's always an exact match. And now we're talking about like kind of this fuzzy
The
matching.
similar matches.
Yeah.
Yeah.
And it's very hard to, you know, this problem, there's a ton of research on, and, you know, we're going to be trying to continue to follow that research and find, you know, what is the right way to represent vectors in the caching world, right? Or these similar matches in the caching world.
I'm pretty excited about the problems here. I'm also super excited about watching Valkey kind of grow into some of the database level asset guarantees. I think last time we met at a Valkey meetup, you were joking that Valkey's got the AI part of asset figured out. So I gotta remember that one. That was a very good AI story for Valkey, that we've got the AI part.
Yeah.
So we
We lucked
the
out.
consistency and durability now, which is true for most of AI stacks everywhere.
Yeah, right.
But this is all pretty exciting. I am looking forward to your talk at Unlocked. I'm looking forward to running some benchmarks on our vector search and full text search, and, you know, kind of keep the momentum going. And it's been just a true inspiration watching the pace of innovation with which you and the whole community has been driving the future of Valkey.
Thank you. Yeah, it's been very exciting. It's an honor.